So in the previous video, I left you with a challenge of trying to implement fmap3, possibly only using an applicative constraint. So the question is knowing that f is applicative enough to be able to implement this, or would we need to add yet another type class for f's which can actually support an fmap3 operation? So let's try this out. So if we have our function g, and I have an fa, fb, fc. Now let's think for a minute. What we did before, right, we know that, and by the way, I added some extra parentheses here. I suppose that wasn't there before. Again, just to help us think about the fact that we can apply this function one argument at a time. So if I say g fmap fa, I'm going to apply this function to every element in this fa, and I'm going to get an f full of functions b to c to d. Okay, and then of course we also have fb, which has the type fb, and I can again use the app operator to apply this f full of functions to this f full of inputs to that function, and I'm going to get an f full of outputs. So if I can say g fmap fa app fb, I should get an f, and the result type is a function from c to d. Let's align these up a little better. Okay. But we're actually not stuck at this point. So notice we now have, right, we have fc, which has type fc, and we can use app again. We can use app to take this f full of c to d functions and apply it to this f full of c's and get an f full of d's, which is exactly what we wanted. So if I take this thing and do app fc, I get something of type fd. Again, we'll line these up. So that's great. That works. So I can write this as my implementation. In fact, we don't need these parentheses because again, fmap has higher precedence, and the app operator associates to the left, exactly so that we can write this kind of pattern. So and you know, as you might suspect, we could implement an fmap4 similarly. So I don't need these parentheses there. Let's take away some of these extra parentheses for now. We'll add another argument or a result type e, fd. All we have to do is add another app and an fd. Okay, so this pattern is going to continue. So it turns out that to go from functor, which can do an fmap of a one argument functor, to be able to do it with two argument functions, we need some extra power. We need applicative, which is gives us something extra over functor. But once we are able to do it with two argument functions, we can do it with functions of any number of arguments just by iterating that app operator. So incidentally, fmap2 in the standard library, fmap2 is called lift-a2. So the A is for applicative. So it's not actually called fmap2, but there are also such things as lift-a3 and lift-a4 in the library, but really, honestly, no one uses them, because if you wanted lift-a3, you could probably just write this kind of pattern directly, and similarly for lift-a4 or any other number of arguments. So again, I want to emphasize that kind of what this looks like, how we can think of this is, we're taking this normal function g, right? So in this case for fmap3, g takes 3 arguments, or we can think of it that way. But instead of, if we just said g applied to a, b, c, we're just applying it to arguments normally. But using this kind of syntax with this fmap and this app operator, we can apply it to arguments sort of in the f world, so in the f context, for whatever f is. And now we get 3 arguments of type fa, fb, and fc, and when we apply it, we get a result of type fd. It's nice that these operators just allow us to write it. If you kind of squint and ignore these operators, it looks like we're just applying g to several arguments, and so that's kind of what we are doing. It's just that they live in this f world. And so the same thing would be true for any number of arguments. You have an fmap at the very beginning, and then you chain all the rest of the arguments with this app operator.